Welcome to the third episode in the series, where I'm learning Python with the help of AI. I'm here today with a crick in my neck. Perhaps not relevant to the stream, but it's very annoying. Last time we did the dice program, the dice simulation as well, or the dice roll simulation in the dice program. It was very complex for a third exercise when coming from basically zero knowledge in Python, but I somehow managed it. Somehow. The actual lecture on what was going on took a longer time to complete than the third exercise, but I think we're ready to move on to the fourth exercise. So let's ask the AI to provide. Please move on to the fourth exercise in the list, or perhaps only the fourth exercise. I don't want to confuse it. I'm fairly certain that sooner or later the AI will start hallucinating and I'll have to restart the conversation in a new conversation, just to keep the memory issues at bay. I honestly have no idea what the fourth exercise will entail, because we done a name script, mini calculator, and the dice. We done variables, we done random numbers, loops, and lists and dictionaries. Alright, perfect. Exercise 4 is about testing with PyTest. We'll write a few small clear tests for your calculator so you see failures and successes, and you'll learn how to run/interpret them. Exercise 4, your first test, PyTest. Why test? Catch mistakes early and with helpful messages, lock in behavior so future edits don't break things, practice designing functions that are easy to verify. You already structure things well in exercise 2, small functions that return values, add subvolume div to float, and operations lookup. That makes testing straightforward. Quick check, make sure you're in sandbox, yes. Wait. And that PyTest is installed. I think I've already installed PyTest. Let's check PyTest version. Yes, PyTest 8.4.1. Alright, create a tests folder and write tests. So we'll be importing functions directly from the minicalc program. Interesting. Wait, create test. Okay, so we'll just create a new file. Create test folder and alright, new folder, tests, minicalc.py. Calc, can't spell for the life of me. There we go. We can close the dice for now. This can stay open as we'll be using it. Wait, did I press something weird? Oh, the cursor changes when you press insert on the keyboard. I must have mispressed it. Pressed it by mistake. I don't like the console-like input method where you write like this and then you overwrite what's already there. I like this version much better. Alright, import PyTest. And this is a module. Module, yeah, it says here, module. Are all imports modules in Python?
In Python, all imports are not necessarily modules, but they often are. Let me explain. A module is basically a single Python file that you can import, but you can also import packages, which are collections of modules in a directory, or even specific objects like classes and functions from within those modules. So imports can be modules, but they're not limited to just that.
I see. So this will basically be us importing functions directly from the minicalc without importing minicalc as a module. So minicalc import add sub motive to float. Oops. I think I'll be skipping writing the comments, even though they might be useful when going back and looking through what we've done. It's simply too annoying to keep writing them out. I could copy and paste them, I suppose. Nah, where's the point in doing that? I can just reference it in this conversation later if I need to. Alright, and what does it say here? Yeah, it just says if it's a function or a constant or whatever. Then we define a function called test to float basic. And we don't specify a return value. Instead we say assert to float 3.5 equals 3.5. Assert is a new way or a new function. Is this a function? Would assert be classified as a function?
Yes, exactly. So something like assert in Python is a built-in function. When you use it, you're basically calling a function that checks if a condition is true. If the condition isn't met, it raises an error. So in that sense, yeah, it's a function you're importing from the built-ins.
So this is basically checking then if the function to float returns the value 3.5, then it doesn't raise an error, I suppose. And if that isn't the case, then it will raise an error. And well, that's the whole point of testing it, I suppose. I'm really misclicking a lot today. Third to float. These are pretty long function names, not gonna lie. With PyTest raises value error. This is a new one. To float, not a number. What is going on here? Test to float invalid raises value error. So does this mean this doesn't raise a value error and simply crashes the program? Or what's the difference? Hmm. Is this supposed to be like this, or is this supposed to be indented? Let's try and write it out. pytest.mark.parameterize parameterize, however you say that, and a b expected. This feels wrong somehow. And we input a little bunch of random numbers without explanation so far. There might be an explanation down below though. Should I scroll down and... yeah, I'll scroll down. No, there's no explanation. What is this for? Expected function or class declaration of the decorator. That line is a PyTest parameterization. It tells PyTest to run the same test function multiple times with different inputs and expected outputs, so you don't copy-paste similar tests. Wait. Mm-hmm. Pytest.mark.parameterize a decorator that generates multiple test cases. A, B expected the parameter names your test function will receive. The list, the data table, each tuple maps to... okay. PyTest will run. Test sub. Receive two separate test instances in the output. Why use it? Dry, no copy paste. Readability, the data table makes the intent obvious. Scalability, add more cases by adding rows. Equivalent long form for comparison. So otherwise I'd have to use a different function for each test then. In this instance at least. Parameterization is just a compact way to do this. Okay, so it's a shortcut of sorts. Nice extras, optional. Name the cases. I'll skip that for now. For floats, compare with tolerances. Alright, let's go back to the actual code here. So after that we have then the function test mul a b expected assert mul a b, and if that's equal to expected. And then if I call this function then it would use these values Will it call the function 3 times then, or will I have to call the function like 3 times to go through each parameter? I guess that will answer itself when I run it, so I don't need to ask for now. And test divide by 0 with pytest dot races 0 division error as xinfo xinfo. I don't know how to pronounce that. And then divide by 0 in string xinfo.value dot lower. I'm still not sure what the difference is between using with pytest races and just using the assert. Should I ask or should I just run it? Let's run it first and see what happens. Pytest Q. Wait, is that actually how I run it? Ooh, this doesn't look good. Error while importing test module. Make sure your test module packages have valid Python names. I must have done something wrong then. Module name, module not found, module name in calc. Did I spell it wrong? Can I follow it? I can follow it. Alright. Mini calc. And that's the only place I actually import it from. Yeah, I have no idea. It might be because I'm in a folder. Can I copy and paste it like this? Yes, it works. And now this is a second copy. Alright, let's try that again. Wait, it's working now. Yeah, here is the beginning. And it's giving errors, but that's the point, I think. Because this is a testing for errors. And here we have done 3 failed, 4 passed. When I import a module in Python, does the script have to be in the same location, like in the folder structure, as the script that's importing it.
Not necessarily. So Python does have a way to look for modules in different locations. By default, it checks the same directory as your script first, but it also looks in other places listed in something called the Python path, and you can tweak that if you need to. So the module you're importing doesn't have to be in the exact same folder, as long as Python knows where to find it.
That's interesting. I suppose I could just ask here. Let's just copy this error like this, and I paste it here, and we'll see what it says. Alright, this error means PyTest can't find minicalc in Python's import path. Let's fix it fast. Make sure the file exists where PyTest expects. From run. If you don't see minicalc.py, create, rename it exact no dashes. Run PyTest in the project root. If they fail, force add the project root. I moved the minicalc.py min. I probably have to spell this correctly or it will instantly complain. I moved the minicalc.py to the tests folder and it suddenly worked. I'm just trying to double check here to make sure I'm not going crazy and to make sure that the AI actually made a wrong assumption or provided the wrong instructions, basically. Nice, that makes sense. When you run PyTest, Python tries to resolve from minicalc import by searching the import path. The current project root is on that path, so modules that live next to tests can be imported by name. By moving things so that minicalc sits in or you ran PyTest from the same project root as tests, the import started working where it failed before. Python looks for minicalc.py in the directory it's listed as syspath, which includes the folder you ran PyTest from. If minicalc.py was in a different subfolder or you ran PyTest from the wrong directory, Python couldn't see it. Simple, reliable layout. Well, that was my layout. And it still didn't work. Make sure you're in the project root when running PyTest. Is that the... no? This is the project root. I'm fairly sure. I mean, it says sandbox and sandbox is the root of the project. Oh, that wasn't my intention. Sandbox. This was my project layout. But it still didn't work. I had to move the mini calc.py to inside the tests folder. I'm also running pytest from, let's just copy this path here from this path. Why is this? I have no idea if they will even be able to fix this issue. It might get stuck in a loop or something. It's happened before. I feel like ChatGPT 5 is especially bad at getting stuck in loops. I've used Gemini 2.5 before, and Gemini 2.5 is so much better at this. The only issue I have with it is the lack of a desktop client like this, and the lack of voice or live conversation mode in on the desktop. It just doesn't work for me for some reason. I don't know why. Okay, let's see here. Good observation. This happens because where Python is looking for modules when PyTest runs. Okay. It works because PyTest always has the test folder in the import path. It should also work, but in your run the project root didn't end up on sys path or from in a fail. Okay. Here are reliable fixes. Pick one. Run PyTest in a way that guarantees the project root is on sys.path. Alright, let's try deleting this one. And for sanity's sake, let's do a PyTest queue again to make sure. Wait, so. Yeah, still the error. And then we try Python pytests queue. Is the Python -m or Python -master, or what does the M signify?
Yeah, so the M actually stands for module. It's basically telling Python.
All right.
Yeah, exactly. It's the handy way to run a module as if it were a script. So if you do something like Python-m, say venv, you're telling Python to run the venv module. It's not about master or anything like that. It's just a shortcut to say, hey, treat this as a module you're going to run.
Okay. I thought it stood for master because like the master branch in a Git project or something like that, but it stands for module. All right. Oh, not dash pytest like this. And now it worked. And the second fix is doing conf tests. Does that mean I can just create a new file here called conftest.py and do the import sys.os and then this sys path.append os path.dirname os.path.dirname __ file __. And now it will just work. It seems so. I still need to ask, because I feel I need to know what does this actually mean / do. I suppose it adds the directory somehow to the path to make sure PyTest actually sees the files, but okay, great question. That two-liner is a quick way to tell Python also look in my project root when importing. Okay. What each piece does, __ file, the full path of the current Python file. In your case, inside a test is roughly, yeah, like that. Strips the file name given the folder that the file is in. One more dir name goes up one level. Oh. So it's checking the directory of the directory. Oh no, it's getting the directory of this file and checking which directory that directory is in. And then it appends it to the path. Alright. I guess that makes sense. And oh, back to the actual testing. Ooh. It was a really long tangent. Wait. Wait, no. Still going up. Up. And we have this here. Def test ops dispatch matches functions. Assert ops plus is add. Assert if ops. Minus is subtraction. Assert ops. Asterisk is, we just define all the functions, and then we have I have a bunch of functions with assert, with, and pytest.races inside them, but I don't actually call the functions from anywhere, but they still run. Why is that?
I see what's happening. So that's actually pretty common if you're using something like PyTest. The reason those functions are running is that PyTest automatically discovers and runs any test functions it finds. So if you have functions named in a certain way, like starting with test, PyTest will just pick them up and run them for you, even if you're not explicitly calling them yourself.
That's actually really cool. I'm almost embarrassed it took me so long to realize I didn't actually call the functions and they still ran. But I suppose me typing in pytest and then -q for quiet automatically runs them. And I suppose they also run... They will run all the tests I have in this whole project directory then, I would guess. And running pytest in a project folder will run every pytest function.
Exactly, that's right. When you run PyTest in your project folder, It'll basically scan through the directory and find all the test functions that match its conventions. So if they're named like test something, or they're in a file that starts with test, it'll run them all automatically. So yeah, it's just PyTest doing its discovery magic.
This is actually really cool. It's a great way to test stuff. And I've never seen something like this before. Alright. Run the tests. You should see dots for passes and a short summary. If something fails, PyTest shows a helpful difference perhaps? Diff/trace. Read the last part first. It points to the exact assertion that failed. So short test summary info, and here it says then test mul for these numbers then 2 times 3 does not equals 5, and the assertion then is false, which means it failed. And the same thing here, -1 times -1 does not equal 0. 0 British, and test _div_by 0. Assertion error, assert divide by 0 in cannot divide by 0. I'm still a bit confused why we use this way of like explaining it. I suppose maybe using assert and trying to... No, we are... That's what we're doing here. 0, 0, 0. We're trying to divide by 0. No, this is multiplication. I'm stupid. Div. We don't actually have a div function except for this one. What would happen if I do this dev test div? Let's just keep it simple and do it like this. Div. I don't know, 1, 0. And then we try and run it again. We have another failure. 4 fail it says now. And here we have _div 0 division error cannot divide by 0. Which makes sense, but I don't get why you would use this code instead of just trying it like this. What's the point of using with pytest.raises 0 division error when I could just use assert and then call a function that divides by 0?
Yeah, great question. So the main idea is that using pytest.raises is a more explicit way to say, hey, I expect this piece of code to raise a specific type of exception. It's kind of like you're telling PyTest, this is the error I want to happen here. So it's a little clearer and more controlled. If you just use an assert and you divide by 0, yeah, it'll fail if it doesn't raise the error. But with pytest.raises, you're making it super explicit that you expect that exact error to occur, and it just makes your test a bit more readable and intentional.
I'm still not sure about the practicality of doing it like that, but maybe I'm simply not understanding the point. With PyTest races as this has to be an exception info, I think. As exception info, and then assert divided by 0 in string exec.info.value not lower. So this here is exactly the same as what zero division error prints up here, it's just been lowered. So the letters aren't capitalized. But as I said, I don't understand the point of doing it like that. Okay. Alright, let's do the test also for the dice. Test dice.py, and then from random, from dice import roll, let's go D, depth tests, roll in range many times, random.seed, and we set a static seed here, sides equals 6, form in range 500. So we loop 500 times. What? Random is not defined. Oh, import, obviously. Import random. R equals roll D sides. Assert 1 is smaller than or equal to R, which is smaller than or equal to sides. So what is this actually doing? We loop through the roll function 500 times, and we check that R is like the dice throw is either greater than 1 or equal to 1, and that R is also equal to or smaller than the number of sides. Since the dice function is implemented correctly, this shouldn't result in any errors. So we should see 4 failed and 6 passed if I run this again. Yeah. Alright. Great. How to read failures. If you break div on purpose, you'll see fail, did not raise zero division error. It tells you exactly which behavior is missing, fix the function, run test again, and the failure turns into a passing dot. Mental model to keep. Arrange, act, assert. Set inputs, call a function, check the result. Test pure logic, not terminal input and output. Input and output is harder to test and not needed here. Parametrization. Do you say parametrization?
I sure do. So you can absolutely say parametrization or parameterization, depending on how you like to pronounce it. It's just the idea of running the same test with different sets of parameters. And yep, PyTest has a nice way to do that too.
Parameterization. Parameterization or parameterization. Or did I say that wrong again? Who cares? Who the fuck cares? It doesn't matter. Okay. When this feels good, we can do exercise 5 next. Split your calculator into modules. Then rerun the exact same tests. No change needed. I suppose. Wait, does this mean that multiple imports on one line? Is it simply complaining because of that? All right. Let's try it like that. Okay, that's that out of the way. Please give me exercise 5. Or let's move on to exercise 5. I think it's better to treat the AI like a partner. It sounds kind of cringe almost, but in my experience it just gets what you're trying to do better if you don't treat it like a search engine or a task engine, like you treat it like a person, which is bizarre, but that's my experience. So yeah, it might be cringe, but that's the way I'll do it, if I remember to. I'll be right back while this is loading. What is going on? I'm dropping frames like crazy. Has my internet died? The download speed is still going strong. And my upload speed is... Damn, it's really low. Are we back? It seems like it. That was really weird. It still says it's pretty low, but the drop frames have stopped. Oh wait, are we still on the same stream? Or has the stream stopped? No, the stream's going. Well, that was very weird. I dropped like 6k frames. Alright, I hope that didn't happen before I went to the bathroom. Because when I came back I saw the stream going haywire. Alright, let's just treat that as something in the past and continue on. And we can close this one. And let's lower this one a bit here. Alright. Then we're on exercise 5 here. Awesome. Exercise 5 is about turning your single file script into 2 modules, one for logic and one for user interaction. This is a huge step towards real projects because it lets you reuse and test logic without touching input/output code. Okay. Split into modules imports. What you'll build: calc underscore operations, pure functions, no input, no print, calc underscore cli, the interactive command line interface that imports calc underscore ops. Your test will target only calc underscore ops.py. Create. Okay, so I can see the logic behind it. Keeping the module separate so you don't have like one huge file that's cluttering up and just being annoying to work with. Multiple smaller files are usually preferred, I think, than like having one gigantic file that's doing everything. I'm just checking in the network and it seems I haven't dropped a single frame since that happened. Which is good. All right. Then do create this file next to a test folder. So out here then. New file. Calc ops and .py. Okay, from typing import callable. I forgot what callable was. Is a class. What's the callable class?
So the callable class in Python is basically a way to check if something can be called like a function. It's not really a class you use to create objects, it's more of a built-in way to check if something can be invoked. So if you say, hey, is this object callable? You're just saying if you can treat it like a function. It's a nice little utility for that.
It's callable, not callable. Callable. Alright, from typing import callable, define the function to float text string, and we want a float in return. And I'm not going to bother with copying that. And just do cleaned text strip. Or replace comma and period. Return float cleaned. Great. And then under add function. I suppose I could just copy this from the other project since I've already done this, but I'm gonna do it again. It's a good exercise, I think. Float return a plus b. Def sub. Float return a minus b. Def null a float b float to a float. Return a times b. And we have a divide function as well. B float, and we return a float. If b equals 0, raise 0 division error. Cannot divide by 0. Oh, is this where the actual text comes from? When we run the errors here? Because we called the div function then. Not this div function, but the... yeah, the minicalc function here. We called this div function. Yeah, and we have the same here. Alright. And this is wrong because we don't return anything yet. Return a divided by b. Ooh, and this is complaining because we're lacking a comma. Yeah, a comma. And then we have the operations table. And it's a dictionary with a string callable. I said that right, I think. Callable. Float. All the floats. And a plus. And a minus. And this is the functions, I think. Yeah. It's a really elegant way to do it. I hope I remember this process. Because I can see the utility in just doing it like this and don't having to call each individual function in another way. This was the whole call. Oops. Scripts. Key idea, these functions return values and raise exceptions, but they never read from input or print to the terminal. So it's pure math. Quick maths. And then we have the calc-cli, or command line interface. calc-cli.py. That almost rhymed. Then we from calc ops import ops and to float. And we don't actually have to import the functions we established because the constant. Ooh, nice. Oh, I always forget to grab my little chest here. A duplicate item, whatever. What was I doing? Oh yeah, we don't actually have to import these functions because we we already called them from here. That's actually pretty smart. And then we have the main function, which is our actual application. Print tiny calculator supports plus minus and division x text equals input first number y text equals input second number, and then we have the operation, which is an input operation plus dot strip strip. So try x equals to float x text, y equals to float y text, and f and ops result was f and x and y, and then we print the result using a formatted string. So result, and then we have the exception error for key error. Print unknown operation, use one of plus minus right. There we go. Except value error. Print, please enter valid numbers. I'm just gonna do it like that. Except 0 division error as E. Print E. So the E variable here will become the this string then, I think, and then we print it, and then the safeguard. Make sure we don't import this as a module. All right. Point your test at calc_ops. Either rename your test file to test calc_ops or just update imports on your in your existing file. I'm just going to do another one because why not? I don't know. Might take some more time, but I feel like the repetition is helping me remember what I'm doing. Test calc_ops.py. To run PyTest, does the script have to start with test? Hello? To run a PyTest, does the Python script has to start with test in the name?
So they don't absolutely have to, but it's definitely the most common convention. PyTest looks for files and functions that start with test of, because that makes them easy to discover. But you can configure it or use other naming patterns if you really want to. It's just that by default, yeah, having test at the start is what makes PyTest recognize them right away.
So it's recommended, in other words. So let's stick with doing that, and then I suppose importing PyTest. Up here is the actual code that makes sure it runs anyways. But let's stick to conventions. There's no need to reinvent the wheel. The wheel. To float. Oops.
I'm sorry, but you've hit the time
Oh.
limit.
Max length. Okay, new chat. Wait, no, not new chat here. I'm going to make sure the new chat is in the correct conversation window. It probably is, alright. It's kind of silly that it says the chat is so long when I'm mostly muting it. It should be like that the AI should like turn off when I mute it, so it doesn't count against the max time of advanced voice mode I have each day, but you can't get everything, I suppose. Test to float basic. Assert to float 3.5 equals 3.5, and then we have test to float, comma, and spaces. Assert to float. Then test to float invalid raises value error. These are some really long function names. Value error to float none. Nani? None? No, none. None. NAN. It has to stand for something. It can't just be gibberish. What does capital N underscore A capital N stand for?
NA or NA typically stands for not applicable or not available. It's used when a certain piece of information doesn't apply in a particular context or isn't available at the moment.
I mean, I know what NA stands for, but NAN, is it not applicable number then? What about NAN?
NaN stands for not a number. It's a term used in computing and mathematics to represent a value that doesn't represent a real number, often resulting from undefined operations like 0 divided by 0. It's a handy way to handle errors in numerical calculations.
No, I'm just gonna keep it like that. Parameterize. How do you say parameterize?
You can say it as parameterize, with the emphasis on the second syllable. It's a common term in programming and mathematics.
Parameterize. That's the difference. Parameterize or parameterize. I think parameterize sounds much better. But I keep saying parameterize for some reason. Parameterize. 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 I don't even know. I'm going back and forth. I think it doesn't matter, but I want to stay consistent at least. And I of course want my consistency to be correct. -1, 1, 0, and then we have 0, 0, 0. And I'm gonna close this one here. Def test add A B expected. Assert add A B expected. I'm just going to copy this one here and change the numbers to 10, 4, 6, and -2, -3, and 1. Define a function called test sub A B expected, and then we assert A B and check if it's the expected number, and we do it again for the numbers 3, 7, and 21, and -2, 5, and -10. Test mode A B expected. Expected. And the last one. The last one. And we have the numbers 8, 2, 4. And 7.5, 2.5, 3.0, or 0. Test underscore div A B expected. And then we assert it again. A B expected. And test the divide by 0 without the parameterization. Without the parameterization. With PyTest raises 0 division error. Div 1 and 0. Test ops dispatch matches functions. Assert ops loss is add, and I'm just going to do it like no, not like that. Exit shift enter is not the way to do it. Then I run Python, I think. That's what it looks like, at least. Yeah, I run Python if I do shift enter, and that's not my intention. And then null and division All right, and this is the test script complete. Run test and decline. And we should be able to simply run the PyTest view like this. Or maybe not. Oh. These are a lot of errors. Wait. No, it's not this. These ones are outside the test folder. But they shouldn't result in errors like this. Oh, a syntax error. Well, here. Wait, was that the whole reason for all the errors? A simple syntax error. Let's try run it again. Yeah. It was literally a single syntax error causing all the or in test add functions uses non-argument expect. Oh, another error. Expect. Wait, did I expected. And now we have wait, is it working or is this not working? Failures. No, this is probably the actually desired result, because it quite cleanly says all the, it even shows the line of the errors, I think, yeah, and everything like that. Of course, we're also testing all the previous ones, I suppose, just doing can I simply comment them out? No, not like that. Maybe no, you can't do block comments like that. I was just curious because now we're also running these functions which are the old ones for testing the dice and stuff. And yeah, we're getting the old errors here. And no errors in the test calc ops. Wait. Are we really not getting any errors in? Here it is. Here it is. Wait, is that because we're actually handling the errors? Oh. So if I were to write like let's say instead of 3.5, let's say 3.5d, that's not a number, and then run it again, and now we get another fail, and yeah, and here it says, no, here it says So it works, it's just that all the error... There was no error. So the testing function actually did basically nothing for now. Yes, we did that. Yeah, let's run the program as well. Python calculi. Tiny calculator. Sprut. Okay, sprut. Oh, here. Supports. First number, let's do 5, and second number 2, and let's do a division. 2.5. And it works. Which is no surprise. But the interesting part is that the whole program we ran basically is this tiny script here. And it imports this function and this constant. It says it's a constant, but I don't know if you should call it a constant or a dictionary. Maybe a constant dictionary. Maybe. Why this split matters. Mental model. Separation of concerns. Calc underscore ops equals pure logic, and calculi is the input and output terminal. Reusability, the same logic can feed a graphical user interface, web API. What does API stand for?
API stands for Application Programming Interface. It's a set of rules and protocols that allows different software applications to communicate with each other.
I got the interface part, but the P was confusing, so it's Application Programming Interface. Or argparse later. Argparse? It says later, so I suppose I don't need to know about it right at this moment. And then we have the testability, test imports only calcops, and stays 100% deterministic. Oh yeah, in the test here, we only import the calcops, so there's no risk of the actual client side of the program confusing the testing. Quick experiments, optional. What does REPL, Python REPL stand for?
REPL stands for Read Eval Print Loop. It's an interactive programming environment that takes user input, evaluates it, prints the result, and then repeats the process. It's really handy testing out code snippets in Python.
After you import, notice PyCache appears now. You've seen module caching in action. I've already done that. We have a cache here. When this is solid, Xi6 will wire out proper CLI with argparse. Okay, so here is the argparse. So you can do Python calc argparse.py 2 + 8. Alright. Neat. So that's exercise 4 and 5. I'm just wondering if I'm going to do exercise 6 now. Yeah, I think I might. I'm just a bit tired, so I'll take a short break for maybe 5 minutes or so. and then I'll come back. So yeah, I'll be right back. Oh, what's going on? Dropping frames again. Over a thousand frames has dropped. I need to run another speed test. Oh, that's not good. That's not good at all. It's actually really bad. I guess I'll just have to wait until we're back. I don't think the stream is even viewable at this moment. My voice is probably chopping like crazy, and the image is probably very poor quality. Or maybe the stream doesn't work at all. Maybe it stands still. I mean, it hasn't dropped all the way. There's still some network traffic going through. But I mean, 5,000 dropped frames. Why does this happen when I go away from the computer? It's like, maybe that's actually the whole reason. As long as I don't use the computer, maybe the network gets deprioritized or something. And this is still pretty long duration. I suppose I'll just have to wait. I can pick up this. Do another speed test. And the download is fine. More than fine. And the upload speed is pathetic. Really pathetic. Your internet connection is very fast, yeah. I'm not sure I'll agree with that, Google. Seems like a poor assessment to me. .30 degrees or something. Celsius, of course, not Fahrenheit, but when I come back to the computer it says I'm dropping frames like crazy again. But now we seem to be back online. And the frames counter has restarted. I have no idea why this happens. It might be because I'm leaving the computer, or it might be... But that shouldn't matter. It shouldn't matter at all if I'm on the computer or not. So I don't know. I have no idea how that will come out in the stream or in the VOD later. But the stream is live, so we'll continue and hope for the best. And hope it doesn't happen again in the middle of the stream. Or in the middle where I'm sitting here and actually doing something. I think I'll actually... yeah, the new chat is here. Annoying, whatever. I think I'll move this conversation into a new window because it's getting a bit too long, I think. I mean, yeah, it's getting a bit too long. I'm worried it might start hallucinate or something, so I think asking for a summary and starting over is the best way to do it. Please provide a summary of everything we've done so far I'm going to copy paste it into a new conversation to continue from there. Include all relevant information. Include all information you'd think relevant to yourself. To think relevant to you'd think relevant. How do I phrase this? You'd need to continue the lessons from this point. I think that's the best way to phrase it. This is all just to keep the hallucination to as low a point as possible, while still keeping the relevant facts. All right. I have no idea if this is actually going to work or if it will increase the hallucination over time, but it's the only way I can see it going forward, because there's a limit to how long you can keep a single conversation going. So sooner or later I'd have to move over to another conversation anyways. So I suppose it's better to get it over with right away. Okay. And then to copy all this, I have no idea if I can actually copy these code windows. Yeah, and I called the AI Rufus for some reason. Wait, here. Let's. Ooh. Yeah, I'm going to do everything, and hopefully the new conversation will. Yeah, the formatting is not ideal when copying it like this, but I hope. I hope this will work. Let's rename this Python exercises 6 plus. And rename this to Python exercises 1 to 5. And we haven't dropped any frames so far. So that's good. And it might actually be a problem where that starts as soon as I let the computer idle for too long. But I mean, it's just a few minutes, so it's still strange. Okay, perfect handover. Let's roll straight into exercise 6. Exercise 6, argument based CLI. CLI. CLI or CLI? CLI. Let's go with CLI. Goal, run the calculator non-interactively. Oh yeah, oh. Okay, you'll learn positional versus optional args, type conversions with your own function, choices, aliases, exit codes, help, and basic output formatting. Okay, please place this in the project root next to calcops.py. So here, calc org parse.py. And I'm just going to copy this actually, because I could have written it out, but what's the point? I can just as well read it myself now. So tiny calculator arc parse version, examples Python calc arc parse. Okay, so this is just examples here, and then Python calc arc parse 1 divided by 0 exits with code 1, prints error to stder. Error here has to be for error, so yeah, we'll get to that. Tips about subtraction: use sub, recommended if you really want the minus symbol, insert the double sentinel. Is that the word for the double minus sentinel? Do we call a double minus a sentinel?
Yes, in some contexts, the double minus sign, especially in command line interfaces, is often referred to as a sentinel or a marker that indicates the end of command options. It tells the program to treat everything after it as a positional argument rather than an option.
And here it says to use the sentinel, then the minus. Okay. And then from future import annotations. What does from _ future _ import annotations do?
The from _ future import annotation statement in Python changes how type annotations are handled. Specifically, it makes all annotations be stored as strings instead of being evaluated immediately. This can help with forward references and reduce some import time overhead, making your code a bit more efficient and easier to manage.
So, oh, I shouldn't have said something there.
So essentially, it's a neat little feature that makes type hinting more flexible and can prevent certain issues with circular imports or forward references. It's a good practice to include it in your code if you're using type hints in new Python versions.
Exactly what I was about to say. Exactly the same. Not. But yeah, I think I get it. Import arg parse. Import JSON. Import sys and import from typing import dict. Is this a dictionary? No. New empty dictionary. I suppose we'll get to that. From calc ops import oops and two floats. Okay, so aliases in caps is another constant, I suppose. and we have the string and string value, and add plus wait, no, plus oh, so we could do it like this, but we're doing it like this to keep all the same operations on one line for clarity's sake, I suppose. And this is so we can write add, sub, or plus, or just a plus sign later in the calculator or in the args. I'm just going to copy and paste this and then do it like this, minus and minus. And well, this is basically all quality of life improvements. And we don't actually have anything for that, so we only have like this. And saving automatically ruins the formatting, or it doesn't ruin it, but it converts it back to the one I'm used to. I suppose it doesn't matter. But map many spellings to the canonical operator symbol used by calc-ops. For a smoother UX. What does UX stand for?
UX stands for user experience. It refers to how a person feels when interacting with a system, product, or service. The goal of UX design is to create easy, efficient, and pleasant experiences for the user.
It's a bit annoying that the window stays this width when I close the sidebar. There's really no point in closing the sidebar if it doesn't expand it. But I might as well do it. No, I might as well not do it like that, because then this is in the way. Where was I? Here. Choices equals sorted k for k in aliases, not keys. So we get all the keys and we sort them. If k does not equal minus, for some reason, and then we have the function colon parse args, argv none, and Is that because we don't actually want an argument here or a parameter here? If I have a function called def parse underscore args in parentheses arg v equal none, what does that mean?
When you define a function with an argument like argv none, it means that the parameter argv is optional. If you don't provide a value for it when calling the function, it will default to none. Inside the function, you can then check if argv is none and handle it accordingly, for example, by assigning it a default list of arguments. It's a common pattern in Python. Can make functions more flexible.
Makes sense. Parser equals argparser.argument parser and argparse. This module is an opt-parse inspired command line parsing library that handles both optional and positional arguments, produces highly informative usage messages, supports parsers that dispatch to sub-parsers. The following is simply usage example that sums integers from command lines. Okay. Argument parser. Oh, it has all the stuff. All the parameters. And I guess we have to fill in most of them. Or all of them. No, only two of them. Prog and description. Prog equals calc arg parse.py. Description equals a tiny non-interactive calculator. And this is... oh. There we go. And then we have parser.add argument a type to underscore float help equals first number and just do first number. Parser add argument. Oh, there we go. Oh. Choices equals choices. Capital choices. And then we have a help operation add sub mul / div or plus asterisk division or plus, not or. And then we have use sub or subtraction. And that's it. And I close this here, so and that variation. And then we have another argument for B. Type to float. Help second number. And we don't actually want a dot or do we? No, we don't want a period. And another argument. P precision type int default to none, and a help. You might want the AG there, minus B3. And one last argument. Format. Choices. Text and JSON. Default. Text and help. Output format. Output format. Default text. And return parser.parse args argv. Okay, and then we have another function, def compute float repeat token string and b float, and we return a float. OP equals aliases. OP operation token normalizes to plus minus asterisk or slash fn. Oops. Grab the pure function. So fn, I suppose, is function. I don't know why we're calling this variable function, or why we're calling this variable fn, but I suppose it has something to do with the function. Return fn ab. I suppose the name doesn't matter, but I'm a bit curious, not gonna lie. Then we have the main function argv equal none. Return none. Args parse args argv try result let's compute args a args op args b except zero division error as e print string e file sys.str raise system exit 1. I'm unsure what that means. If args.format equals JSON, print JSON dot dumps a args a op aliases args op b args b and result result. Args. Args. Else. If args dot precision is not none, print f string result. Dot args dot precision f. Else print result. Ooh, this was a long piece of code. The longest yet, I think. Perhaps not, but the densest by so far. By far. Okay. We're still not getting a good explanation on everything here. Why these choices quickly? Your own to float as type pushes parsing relation onto the binary. He gets clean float and supports 3,14. Choices arg parse prints friendly errors for unknown operations. Exclude minus from choices avoids looks like an option ambiguity. Use sub or the sentinel. Xcode 1 on errors. Let script slash tests detect failure messages goes to stdir. What is stdir? Hello? Rufus? What is stdir? He crashed. What is stdir?
STD is typically an abbreviation for standard, and in many programming contexts, especially in C++, it refers to the standard namespace that contains the standard C++ library features. In other contexts, it might mean something else, but if you're dealing with C++ or something similar, STD is
What about in Python? It's stderr.
In Python, SDERIA stands for standard error. It's one of the three standard streams, along with std in, standard input, and std out, standard output. SDERIA is used for outputting error messages and diagnostics so that they can be separated from the regular program output. It's especially useful for debugging and logging errors.
Okay. I feel like I have to get some clarification on a lot of stuff here. Oh, I'm dropping frames again. How long have I been dropping frames? For a while. Then it's not the... Then it's not actually me walking from the computer, it's a greater issue. I think I'll have to pause it here then and go through everything I've done here next time, because it's not fun to keep dropping frames all the time. It's not great. So yeah, I'll stop it here for today, and we can go through everything next time and try to understand what the hell I've created, because this is spaghetti code to me right now, if that's even a way to explain it. Spaghetti code, I've heard that somewhere, but I don't know where. Yeah, Well, this is that for me today. I'll see you in the next one. Bye.